calorimetry. Calorimetry is the measure of heat flow. The device we use is called a calorimeter device to perform calorimetry. If we have an exothermic reaction, we often call a bomb calorimeter, where exothermic reactions take place. Don't get too excited with the term bomb. It just means that heat goes off in it. Your bomb calorimeter is mean 2 styrofoam cups. All right, so there's a couple terms we looked at last year. Specific heat, amount of energy raised 1 gram of substance by 1 Kelvin or 1 degree Celsius. And Q, which is the specific heat times M times C times delta T. That's the equation for heat of fusion, vaporization. Heat of fusion, amount of energy to raise 1 gram of substance to a solid to a liquid. And heat of vapor is the amount of energy to boil 1 gram of a liquid to a gas. And there's my equation, Q of F. So we have all our terms here. Remember, the C of F of water is 336. C of V is 2270 joules per gram. The C of the specific heat of water we dealt with last year. We also have the C of ice, which is 2.010 joules per gram degree Celsius, and the C of steam, which is 2.00 joules per gram degree Celsius. All right, so first thing you have to do is understand that if we were to take time versus temperature, that'd be a 5-step process. First, we have to heat the ice. Then we have to melt the ice. Then we have to heat the water. We have to boil the water, and then heat the steam. It's going to heat the ice. So we're going to take the specific heat problem, so M times C times delta T. Our mass is 134.90. Specific heat of ice, 2.010 joules per gram. And it's 23.99 because negative 23.99 is 0, it's 23.99. We multiply that, we get 6,505 joules. Then we take the C of F, the Q of F rather. We're going to melt it. So that's M times C of F. The mass doesn't change, it's still 134.90 grams. C of F of ice is 336 joules per gram. Multiply through, we get 45,326 joules. We then have to heat the water. So that's going to be M times C times delta T. It's going to be 334.90 joule grams times 4.184 joules per gram degree Celsius times 100 degrees Celsius. We get 56,442 joules. Because that 100 degrees is absolutely significant and the 4.184 is absolutely significant, we go to 134.90 for our sig figs. We have the Q of V, which is M times C sub V, which is going to be 134.90 times 2270 joules per gram. We get 306.220, 5 sig figs again. And then lastly, Q of steam, M times C times delta T. We have 334.90 grams times 2.00 joules per gram degree Celsius times 35.90 degrees Celsius, because 135 from 100 is 135.90. Multiply through, and we have 4 sig figs. We only have 3 sig figs. Use a bar. Add them all up. We get 424,203 joules. That's my answer. Okay, copy this one. We'll do this in class. All right. So next we'll look at a heat capacity. This is the amount of energy absorbed per change in temperature. And we find that by taking the capacity times the temperature change. That's the energy that's going to the calorimeter. Now we find capacity by doing a little problem with the following. Turn the heat capacity of a calorimeter. If 50.0 milliliters of water in a calorimeter starts at 21.4 degrees Celsius, and after 50.0 milliliters of water at 50.0 degrees Celsius is added, the final temperature is 40.7 degrees Celsius. So to find the capacity, we're going to Q of hot minus Q of cold. Absolute value, because we want negative numbers, and divide by the temperature of the cold. So let's start with the Q of hot. We're going to take M times C times delta degree. Now we have 50.0 milliliters, density of water is 1, so I have 50.0 grams times 50 water times 15.2, because hot, 55.9 minus 40.7 is 15.2 degrees Celsius. Cool, that gives us 3,183 sig figs joules. Q of cold, M times C times delta T. Again, 50.0 is a milliliter, so it's 50.0 grams, 4.184. And the cold goes from 40.7 from 21.4, that's 19.3. Multiply those together, I get 44,004 joules. Subtract them, I get negative 860 joules, but that's the opposite value. Sig figs, last field column, gives a bar there. We divide by the cold, which is 19.3. Capacity of the calorimeter, the amount of energy the calorimeter absorbs, is 44.6 joules per degree Celsius. And that's my answer. Okay, copy this one, we'll do this in class. Copy this one down, we'll do this in class. All right, that's it. Take care, be good, bye.